thank you very much for joining us this afternoon. Just a bit about the structure of what we're going to do. Aiming to take maybe an hour, 30 minutes, definitely be finished by 5:30, if not a bit before. We're going to build in some short breaks in between sections. Mainly, we're here to share lots of our resources that you can access through our website, the National Schools Observatory, that will go through all that. So I will be talking about a lot of our resources. I will send out links to all of them afterwards. You'll get them in an email. So don't worry about having to grab links as we go on or write things down. You'll get them all afterwards. If you have any questions as we go along, please put something in the chat. You can type in the chat as we were doing just then, and Ali's going to keep an eye on it and shout at me if I don't look at it often enough. Or if you want, you can use the reaction button to raise your hand if you want to speak up and ask a question, either with or with your camera off. So we're going to do a bit of an introduction to who the National Schools Observatory are, and then cover two main topics, sort of the sun, earth, moon, so day, night, and the earth's moon, and then our solar system. And then at the end, we'd like to get a bit of feedback from you about what you thought of this workshop and what you'll take away from it. So unless anyone's got any questions about that, I'll press on. All right. So a bit about who I am and who the National Schools Observatory are. So I'm Dr. Jenny Claydon. I've got a background as a researcher studying meteorites. I also have a PGCE in primary education, though I quickly moved out of primary education into museums education and working in outreach. So I have a bit of a background, but definitely not as much experience as you, but hopefully from the National Schools Observatory, be able to use our expertise and space knowledge to support your teaching. So at the NSO, which we often refer to ourselves as, I support schools and teachers and students to use our resources and activities. We aim to support your students and you to do real science, for students to apply the knowledge they've learned and use scientific instruments and software like a professional astronomer would. Our content is written by professionals. They've got expertise in astronomy, so you can trust the things you read on our website. Everything's written by professional astronomers, fact-checked, so you can check that. We try and keep our resources as up to date as possible, but we are always looking for feedback. So if you come across something that doesn't quite fit or you think is out of date with your teaching practice or curriculum needs, please always let us know, because we try and respond as much to our users. They bear in mind we are a small team, so sometimes things can't be done immediately, but we will keep in mind all of the feedback you give us. Because our motivation is really to create resources and activities that work for you. So today you'll see some of them that we think are suitable for teaching primary age children in the UK. So primary, when I refer to primary, I'm based in England, even though we're the National Schools Observatory, so I'm sort of thinking from age 5 to 11. So I realise if you're elsewhere in the world, that the stages vary. And if you're in England or Wales, year 5 is often when teachers teach the space topics. So a lot of our content is sort of written for pupils around the age of 10, but we do cover a wide range. So that's sort of a bit about the NSO. We've been built around the Liverpool Telescope. This is a robotic telescope that can be used anywhere in the world via the internet. So robotic telescopes are designed to work automatically without human operators, and they're usually located in remote places on mountain tops. So the Liverpool Telescope is not in Liverpool. Weather's not great in Liverpool to do astronomy. It can be a bit drizzly. I'm actually in Manchester, where it's even worse than Liverpool. So it's on this island of La Palma in the Canaries, in the middle of nowhere. There's quite a few observatories there because the atmosphere is really clear. There's not much light pollution. There's good weather, so it can observe for around sort of 300 nights of the year. I don't think you'd get anywhere near that in the northwest of England. So we have this robotic telescopes that the astronomers use, and the National Schools Observatory project is designed to let schools use the telescope remotely through our website, but also to create resources and activities support general teaching of space and physics topics around it. So we are part of a university. We're part of the Astrophysics Research Institute at Liverpool John Moores University. Liverpool's got a great tradition of astronomy, going back to the early 17th century, I think, and the Liverpool Astronomical Society is one of the oldest in the world. And we have researchers on site who use the telescope to study things in space, like exploding stars, massive galaxies, search for asteroids. They also research how the universe and galaxies and stars form and evolve over time. And they've developed a lot of their technology used. So with the NSO, we're very much about STEM, not just science, not just physics, but sort of all the bits that go into scientific research, the engineering, the technology, the maths knowledge. Our researchers also apply their astronomical knowledge in areas you might not expect. We have an astroecology research group who use astronomical research techniques to monitor endangered species. So that picture of the rhinos, that's actually part of a project done with Knowsley Safari Park. So on our website, you'll see when you get a chance to explore that we're very much about showing how you can apply science skills in a wide range of careers and different subjects. So those of you who have registered, this is what our website looks like. I can give you a quick tour and show you where to register if you haven't already. So I think we're going to take a very, very short, like 2-minute break just after this to give people a chance to register while Alison and I are here in case you have any trouble. But just to show you sort of the main bits of our website. So Learn, this is sort of our textbook about space, and it's written by professional astronomers. So you can use this to support your subject knowledge in case you're not sure about, maybe you want some extra information about a dwarf planet. We've got stuff about dwarf planets in here. Or if you want to know about galaxies, not sure how to define a galaxy or what they're made of, we've got all that in there. And as I said, this is fact checked by people working in astronomy, so you can rely on this. You could also use it as an opportunity for students or pupils to do some research. If they're researching a planet, we've got lots of information on each of the planets in our solar system section there. So it's a really big wealth of information there. So the Learn bit's a great place to start if you just want sort of subject knowledge. We have our teacher section. So if you're registered as a teacher and logged in, this is what you'll see. So we've got a whole getting started, and this goes through requesting observations and using the telescope. We've got our teaching resources, training and CPD. We've also got some of our activities in Welsh language as well. So this is a great place to explore in your leisure. Look at all that stuff that's dedicated there for you. Discover, that's where we've got some of our sorts of quizzes and simulators and calculators. So if you want to just sort of check pupils' knowledge or give a refresher, you can go and find one of our quizzes about the solar system or maybe about the Apollo missions. And we've got some simulators and calculators to sort of explore gravity and ages and other planets and things. And these are all made in-house. So if you come across something and you think, oh, that could be really useful, but I wish it did that, or it'd be really great if there was something like this for this other topic, please let us know. As I said, we're a smallish team, so we can't promise to create something new straight away, but we will take on board any of your feedback, because we're here for you. So we really want to know what would be useful for you in your teaching. And then the main bit of the website is the Go Observing bit, where you can request observations from the Liverpool Telescope. We're not going to go into Go Observing and using the telescope so much today, just because a lot of the activities are more for secondary. But you can book onto one of our workshops, Access the Universe or Explore the Universe, taking place in November and December, if you want to know more about using the telescope and what you can do with the data. Definitely with year 5 and 6, we have some workshops that you could do that for, and there's some good sort of ICT crossovers, but that's not going to be covered so much in this workshop. We're going to focus on sort of practical hands-on stuff about the solar system. But do explore it, get in touch if you have any issues. Use the getting started section in the teacher bit. Definitely using images as well as models can be really useful, because it's really key to I'm trying to say, it's key to reinforce the idea of Earth as spherical, as this spherical object. So if you just use sort of images, it doesn't really show that, because you're just seeing it as a circle. So it's really important to have a globe or something in your classroom, make models using modeling clay or paper mache and things like that. But you can get lots of different images of the Earth as well from the internet. So showing the Earth from different views. So trying to sort of show it from a view with the Americas or Asian continents, so not just sort of one view, showing it from a different perspective. There are images you can look at sort of from underneath, and things like Google Earth are great for being able to manipulate sort of 3D models, and NASA has lots of animations and GIFs and 3D renderings of Earth and other planets that that you can use, and sort of use the image as an opportunity to sort of start children talking about what they can spot. Can they spot somewhere they've been on holiday? Can they spot somewhere a relative lives? And so sort of get that connection, and then also get them noticing things about the Earth's geography. So, for example, that the clouds are part of the Earth system; they're not extending out into space. So, yeah, images are really useful, but just sort of be careful to show different images of different perspectives, and like this NASA revolving image is a good one, because it sort of doesn't just show the one perspective of the Earth. Another thing to bear in mind with images is that often if we see images of the Earth and the Moon, you're just seeing one side fully lit by the sun, so you're seeing all the daytime side. So as well as showing those kind of things, you can find images where the Earth and the Moon are partly in shadow, so you can sort of start thinking about day and night, not just on Earth but on the Moon and on other planets. So pupils might be used to seeing the Moon partly illuminated, but they might not have seen that sort of view of the Earth before, and you can use these sort of images to sort of prompt discussions. So sort of thinking about, so what's different from the previous picture. So you've got the picture where they're fully lit and the picture where they're half in shadow. So what's happening? What do you think's making it happen? Where do you think the light's coming from? Or Dave's put something useful in the chat saying Google Earth Studio can be used to create your own zooming in and out animations. You register, but it's free for educational purposes. Oh, that sounds like a really good link. Yeah, so Google Earth, it's really, you can sort of zoom out from Earth and see all the planets and things. And again, NASA's a great free resource. These images have just come from Microsoft in PowerPoint. They have the new versions of PowerPoint have some animations built in and some 3D models. So you can sort of move them around and show them from different points of view. So that can be a useful place to look as well, just within Microsoft, if you have that in your school, what's in there in terms of the 3D models they have. I think they have cut-throughs of the Earth and solar systems and things as well. And yeah, and just finding examples for all the planets. So there's day and night on Mars and all the other planets. So just getting that idea that the light is coming from the sun. And then it's not just Earth that has day and night, and then we have day and night because we're getting that light from the sun. And you could talk about the terminator, that line dividing the daylight and nighttime side. And I think we do have, I'll come on to that in a second, should have put it here. I think we do have a workshop that I'll come on in a second that talks you through setting up a model using balls and a torch, and goes through sort of some of the misconceptions and the knowledge you need, and using the support from the Learn section. That's a good fact-checked workshop to teach day and night. I was also going to highlight the if you haven't come across them, the resources like Explorify from the Wellcome Trust. So they do lots of their what if questions. So you can use an image as a prompt or a GIF or an animation like this. So things like what would happen if the Earth didn't rotate? What if there were two suns? What if the sun rose in the west and set in the east? So those sorts of challenging their thinking can maybe help sort of unpick some of those misconceptions and get discussion going. I think space is a really great science topic for talking and discussion in the classroom. We have some animations as well that might be helpful. We have a night and day set of animations, so you can download a few of these. We've got them in each of the seasons and different hemispheres, so you can, I'll be able to play that again, so you can sort of compare and use them. So they're quite simple and small animations that you can pop in your slides or whatever. And we have phases of the moon interactive animation. I might just pop and show you properly on our website. So sort of a cartoon style animation of the moon. So you've got, oops, I was trying to find my laser pointer. Never mind, I'll pop back to it. So I'll just use my mouse. Can you see my mouse? Yes, hopefully. So you've got the moon sort of being viewed from the North Pole and the moon moving around it. So you can see they're both lit on one side from the sun over here. And then over here, it shows you the phase of the moon as the moon orbits. And it's interactive in that you can sort of click through this. So it's sort of a calendar, but it's just the date, a lunar month. So it's not any specific month, but you can sort of click back and click around like maybe 2 weeks apart and see where things are. So that's sort of a nice thing that you can use in the classroom as well. And yeah, these animations and things, we create our own, so you can get in touch if you find them useful. That's great. We love the feedback. And if you want them to do something else, or if you want something similar for a different topic, please let us know. Sally said it's been good. Oh, good. I'm really glad. So yeah, so that's it. This link to this animation and all the other things I'm showing you, we sent out afterwards if you haven't come across it already. And yeah, I think said using models. Yeah, so this is our workshop, so on day or night, which allows people to view the Sun, Earth, Moon system from different viewpoints. So it was 3D objects. So we've written this one, so hopefully should avoid inputting any new misconceptions. Because I was sort of just Googling, I think I was looking on Pinterest for some Earth, Sun, Moon models, and I came across this one. So in this image on the right, I was wondering if you could maybe pop in the chat or say something good about this image on the right, and something maybe that's not so good about this image on the right if you were using it as an activity to teach the Earth, Moon and Sun system. So one good thing I think about it is that you've got the Earth in the middle and you've got the stick through it so it can rotate. I think that's a good thing. And I think over here, they've got, I think, a hole with a torch. So you've definitely got a light source. Does anyone see anything that's maybe not so good about this craft model that might reinforce a misconception or introduce a new one? Oh, yeah, the moon is stationary. Yeah, so the moon is painted on the side over there, so it can't move. Yeah, it makes day and night on Earth fairly clear. Yeah, so you've got the night time and daytime, but suggests the moon's still. Yeah, the axis is just straight through the Earth. It's not tilted, so this Earth wouldn't get any seasons. Yeah, it might lead people to think the moon only appears at night because the moon's shown over on the nighttime side of the Earth.
And that the sun's only there during the day.
Yeah, sun's only there during the day. Yeah. So also the fact that they've got the stick so the Earth can spin, but they've coloured in a nighttime side of the Earth. So it's sort of, you've got the light coming from the sun, but you've also got sort of this permanent dark side, even if you rotated it round.
And clouds out by the sun.
Yeah, you've got the clouds out by the sun, so the clouds aren't part of the Earth's atmosphere. They look like they're out in space. So it's just when you're using models, and just to think about all the things that you could accidentally do. So that's why we've got our trusted resources on our website, used by lots of teachers, and we welcome feedback. If you think they're not quite right, we will change them straight away if you spot any errors or inaccuracies. But yeah, do go to us and other trusted resources maybe than Pinterest if you're teaching a topic that maybe you don't feel your subject knowledge is so strong in. And also, when you think about the moon, it's a great opportunity to make observations. So astronomy is all about making observations. It's an ancient science. A lot about what we know about today's cycles of the Earth and Moon were known thousands of years ago by people observing and using maths. So it's a good opportunity for them to observe an astronomical object, sort of the biggest one in the sky that they can safely look at directly. So we have templates to make a moon diary, so they can look at it every day. And I think a tip is to complete a moon diary during school time, maybe to reinforce that the moon's visible in the daytime rather than setting it as sort of after school evening homework. Go out in the day and try and look at the moon and see what it looks like. If you want to sort of plan when to look at the moon, when there's going to be a full moon or the different phases, we have an interactive calendar on our website that updates. Let me, have I got it up here? No, well, I can send you the link afterwards, but basically you can just put in the month, make sure you put in a year, submit, and then it will just update to show you the lunar calendar for that month. So that's there for you, so you can plan your activities. And one more thing that we have, one more thing we have as well is our mosaic, which is a large scale image of the moon, sort of, it's like a big jigsaw, and it's been made from data from the Liverpool Telescope. So the Liverpool Telescope has observed the moon in bits, and we've made the data and images available for you to use in classroom investigations. So got a picture here of some secondary students using it, but we have an activity for primary students just to assemble it, because it's quite big, quite a lot of pieces, and just look at the moon in detail. You can also, we have different versions of the mosaic when the moon's in different phases. So you can put together, you have groups working on different phases and compare what they can see. And we've also got maths activities for counting craters and sort of beyond primary, maybe calculating the height of mountains using shadows and bits of algebra. So we've got those activities that use our actual data from the telescope. We've got a tip from Ali. When you print your mosaic out, make sure they're square. So, oh, did this school stretch the images to fit the page? I didn't realize that. So yeah, so in your printing options, you have to just make sure you tick keep original scale, I guess, rather than print to fit. That's a good tip. So we have that mosaic as well, and that'll be in all the links that I send out afterwards. So I think in terms of day and night, we've had that nice chat about misconceptions, talked a bit about the models. We've got lots of animations that you can use in the classroom, and do give us feedback on them. The other main sort of topic often covered in primary is our solar system. So our solar system is everything bound to the sun through gravity, which includes the 8 planets, their moons, but also lots of smaller stuff like dwarf planets, asteroids in the asteroid belt mainly, comets and things out in the Kuiper belt, cloud of icy stuff in the Oort cloud way out there. But yeah, the key thing is 8 planets and 1 star, the sun. And it's about 4.5 billion years old, and all formed from a cloud of gas and dust that collapsed due to its own gravity. We think our solar system is not unusual. Probably all stars have systems of planets around them that we call exoplanets. So we assume there are billions of planets in our galaxy in the Milky Way, and scientists are managing to detect more and more exoplanets these days. It's a big area of research. Children might be interested thinking about other worlds as well as their own solar system. I think scientists have found about 5,000 exoplanets now in various ways. So we talk about our solar system, which is our sun and the 8 planets that orbit around it, but there are other solar systems out there. It's just something to keep in mind. So again, I've just sort of summarized some key knowledge in this sort of topic about the makeup of the solar system, also appreciation of size and scale that we're going to talk about. And the point that our understanding of the solar system is developed over the time through scientific study. For example, the idea of Pluto being classified as a planet, and then from 2006 is classified as a dwarf planet. That's come about through scientific study, better telescopes, better detection methods, finding lots and lots of smaller things out past Neptune, and having to sort of step back and reclassify the objects of our solar system. So that idea that science is sort of evolving and changing based on the on your current understanding, based on the best knowledge we have at that time, you can show that through solar system science when talking or discussing the idea of Pluto being reclassified. Resources that can help you teaching solar system from the NSO. One of those big topics, thinking about size and scale. So again, it's a great idea to think about models. So, but like before, maybe getting out on the playground and sort of making a scale model using pupils, if you can work out the scale of where the planets are. But we also have a couple of activities that you can use to illustrate the size and scale of the planets of the solar system. One is sort of our Play-Doh planets activity. We have instructions and we have a video on YouTube. I'll play it on my computer. It might be a bit stop-starty. I'm only going to play a little bit anyway. So the link will come out in the email afterwards. So if you can't see anything, don't worry, you'll get a chance to see. But basically, it's using some tubs of Play-Doh to create the planets to scale. And pupils have to apply knowledge of fractions and following in instructions carefully to complete this correctly. So you can use the video in the classroom, but we also have sort of the set of instructions. As this plays, you'll see sort of me creating some planets as we go on. But I think a nice thing to do additionally to just making the scale planets and thinking about fractions and carefully measuring and following instructions, a nice thing can be to give the pupils 2 different colors of Play-Doh, and with one color they can make a prediction, so they can make what they think the scale planets are. So think maybe how much bigger Jupiter is than Earth, and then follow the instructions to make a true scale using the same amount of Play-Doh, and see compare their predictions to the result. I could sort of skip to the end where you've got sort of all your planets to see if any of them really appreciated how massive the gas giants are in relation to the terrestrial planets. So that can be a nice sort of extra bit just to making the scale planets, is to sort of think about prediction and comparing and sort of addressing what they thought. We have a similar thing with our solar system in your pocket activity, which was the thing I was going to get us to do, but I don't think I will because it will take up too much of your time. But that's in a similar way thinking about the distances between the planets. So you can do it with a bit of till roll, a long bit of paper. We've got all the instructions and we've updated our instructions, so it no longer refers to Pluto, it refers to the dwarf planets, and they're putting the 8 planets in between them, so that should be all up to date. And again, it's sort of kind of comparing and contrasting what people think maybe the distances between the planets to the reality. So you can have 2 strips of paper, one with your prediction, spacing out the planets in the order against what you can test. They can remember the order, and they can predict where they think how far is between the planets. And then by following our instructions, they can find out the true scale. And again, it references fractions as well when folding the paper. So I think those 2 activities are good ways to sort of help enforce the size and scale, but also add that extra sort of bit about making a prediction and comparing what is the reality, alongside making big models, maybe across your classroom or in the playground. I think when I was at school, we decorated the hall with sort of a scale model. That was fun. But yeah, all those links to those things will be in the email you get. So I'm just going to skip through the bit where we were going to have a go at that so that I can show you something else that will be useful, which is our electric orrery. So planets are very rarely in the same part of space, so they don't line up very often, if at all. So as we were saying with the pictures of the Earth and Moon, thinking about showing different perspectives, maybe the Earth partly in shadow, different phases. Again, if you just sort of Google for an image of the solar system, often you'll find things like these images where everything's just in a line, and this isn't the reality of our solar system. Everything's very spread out. So it's important not to accidentally teach that the planets are always in a straight line or in the same area of space. So you can get different sorts of angles, but you can also use our orrery on our website. So an orrery is just a model of the solar system, and it knows the speed that all the planets are traveling at, so it can predict into the future where they will be on a particular date. So if I just switch to that on our website, it's here. The link will be in the email. So I think we can just say today. So at the moment, I think we've got the Sun, Mercury, Venus, Earth, and Mars. We've got the inner planets. So down here, I can choose to show the visible solar system. So these are the planets that are visible with the naked eye. So you'll see Jupiter and Saturn. They've been quite visible at night recently. Or you can choose to include the outer solar system as well. I'm just going to pop back to the inner solar system. The play button just sort of starts everything spinning, and at the top you can see the date changing. If you want to go a bit faster, there's some buttons here. I don't recommend pressing that button unless you want to feel a bit seasick. But as well as being able to just fast forward, the buttons by today, you can just go forward a day at a time, or a month at a time, and a year at a time. So pupils might want to see where everything will be, maybe on their birthday or on the day they're doing an assembly or something. So you can use that to explore. And I think, oh yes, thank you, Paul. Well, usually everything on our website says not to scale, but I don't think this does. But yeah, Ali, do you know, is this, I'm assuming this isn't quite to scale, but yeah, so just to remind them. Oh, and you can go back in time, so to when the day you were born. So you can find that as well. You've got the buttons on the other side, so you can go way back. Alison, do you know how far it goes back? Actually, I've never tested it. Could you go back to like?
It's a long time, but I don't think it's like the start of the universe or anything.
But like if you were doing the Great Fire of London, could you go back to them maybe? It'd be a lot of clicks.
Remember. Yeah, it'd be a lot of clicks.
Yeah. So
you can go pretty far back, like within all of our lifetimes. I think you can go back.
All right. So that's there as well, and that's really good sort of thinking about how the planets move and showing that they're not always in the same space. 2 seconds after the Big Bang, don't think so. Not even 2 seconds after the start of our solar system. I think that would be a lot of clicks, 4.5 billion years worth of clicks. Right. And last couple of things, I think I talked about this a bit at the beginning when I was showing you the tour of our website. Just in our Discover section, we have all these quizzes. So we've got like a planet facts memory game where you sort of click and have to pair them up, remember where they are, and it gives you some facts where you have to, there's another one dragging the planets into an order, and then just sort of a quiz about the solar system. So you can use these to sort of test and consolidate pupils' knowledge, or if they're interested in space, want to do some quizzes for fun, that's all there and accessible to them. It tells them if they got things right or not. And we also have lots of other resources for sort of learning across the curriculum. So I think I've mentioned a couple of our activities that involve maths, like the lunar craters, but we also have some literacy activities. We've got one on biographies on the British astronaut Helen Sharman, and then this set of lessons on light and mirrors is sort of set out like a sort of a mystery. We've also recently added a history section to the website. So we've got a big timeline, interactive timeline of history, and a whole section about the history of astronomy and significant figures. And we've made a big effort to make sure that that history section isn't just focused on Western achievements. We've got lots of non-Western scientific achievements in there. Also, some newer activities we've added in the last year are, there's a debate activity you can use. There's one that's more for sort of early years, year 1 or 2, based on art and design, sort of the stories of the stars, of the constellations. And we have our space jobs lesson, which is based around careers to do with space and thinking about how to address stereotypes, particularly stereotypes around gender. So those are all there available on the website as well. So if you're planning a space topic, you can use our resources in different lessons and across the curriculum. Right, I think it's about time to wrap up. So just to let you know sort of what next, please do make sure you're registered, make sure you can log in and have an explore of the website. If you're not sure about anything, get in touch. We have a teacher newsletter that goes out once a month that tells you about events, about new activities or resources we've added, or projects that are going on. So when you've registered in your account settings, you can opt into our newsletter. Please have a go at using some of our activities and resources in the classroom and give us some feedback. Let us know how you get on. If you ever want to ask us a quick question or talk something through, we're starting some online drop-in sessions in September. So we're doing them once a month, just from 4 to 4:30 once a month on Zoom. I can show you where to get to them because these are just for our teachers. So within the teacher section of the website, if you go down there as a sort of a training and CPD, you'll find in the menu, and in online drop-ins, you go there and it's got the Zoom link to join us and all the dates. So if you ever just have a quick question or want to chat to us about how an activity could be improved or a new activity you'd like to maybe develop, or if you want to work with us on anything, please do join us on one of those online drop-in chats. And as always, you can always get in touch with us via email.